Okay, thank you. Good morning, everyone. My name is Dan Jamison. I'm a federal account manager here on the federal team at Tripwire. I handle civilian accounts as well as the U.S. Navy and DISA as part of my territory and responsibility. I'm joined this morning by Dave Henderson. Dave's been with Tripwire for over 12 years, and he is the manager of our systems engineering team on the federal side.
Hello, everyone.
So this morning, we'd like to just talk about what Tripwire is and does and how that relates to zero trust and how and why it should be a part of a zero trust architecture. What Tripwire provides is file and system integrity and secure configuration management and compliance. And we feel like those aspects of an architecture, things that typically get overlooked in most of the zero trust architectures that we look at, and they are foundational to a lot of the components that make up a zero trust architecture. So we're going to address some of that today and hopefully generate some discussion around that topic. So let's get started. So again, we feel like you need to build a foundation for zero trust, and that's more than just having the components, the typical components that most people identify with zero trust. Obviously there's a lot of different models out there, risk management frameworks, but they all have a lot of things in common. And one of those is zero trust isn't a product. It's a concept, and it's an evolving concept. So we've seen that over the past year, how zero trust itself as part of a risk framework has evolved and developed. And a lot of that's been based around microsegmentation, IDAM or ICAM for network access. And actually I need to minimize this window. I can. Sorry about that. Let's go back up. And the policy that evolves around trust. So at Tripwire, we like to say every incident begins with a change. Change isn't homogenous. There's changes that you want to have happen on a network that happen every day, and they're good things. And then there's some that aren't. There's some that aren't authorized changes, and you want to know when those things occur on a network and what you can do about them. So internally, you might have a change in, for example, firewall permissions, storage permissions, user permissions for user accounts, establishing a new user account, a change in a database configuration, some new software that might have been installed, might have been something you wanted to install, might have been something that was dropped on the network. Externally, you might have a new vulnerability that's been discovered that was out in the wild. Somebody gets access to things through, let's say, compromised credentials or something like that, and they get onto the network. But all these things are going to create a change on your network, and they're going to be something that could be monitored and alerted to. And any real incident is going to involve multiple changes, as I just mentioned. Some of those changes in and of themselves don't look like they're anything malicious. However, if you put 4 or 5 of them together, they can be part of a planned attack, and things like the MITRE attack framework can scan your network and basically say 2 + 2 = 5 and say that you've got something in the works that's going to affect your network adversely. MITRE attack framework is part of what we include in Tripwire Enterprise, by the way. Here's just some of the things that can happen that would identify. So again, integrity monitoring is more than just change detection. The main thing that we want to emphasize is with Tripwire, when we start out, we establish and maintain a trusted state. And that's done through establishing a trusted baseline, first and foremost. And we're going to look at every asset before we begin to monitor the network. because without a baseline, you have nothing to compare things to. So as I mentioned, we're going to detect changes to that baseline, and the baseline is going to define what to monitor for what's authorized and unauthorized. We're going to update the baseline with authorized changes. We're going to basically reconcile those changes. If it's good, we're going to promote it. If it's bad, we're going to pass it off to a ticketing system or a security analyst for some type of disposition. And we help to automate that. And in doing that, we help to investigate the unauthorized changes, because some of those changes could be malicious, but it just might be part of a broken process or a mistake made by one of your personnel. So because of that, we feel integrity monitoring is really foundational to zero trust. So when you take all those components that typically make up a zero trust architecture, they've got a secure configuration state that you're going to want them to be in. They all have operating systems, firmware. These are things that can be altered, changed negatively, that could impact you adversely. And so it's very critical that you monitor these things in real time. So zero trust relies on trust, and you have to establish trust. So again, going back to the notion of a baseline, you want to set up that initial trusted state for an asset and for your network. Integrity monitoring is going to ensure that those changes don't cause any one of those assets to deviate from its trusted state, or at least if it does, give you the ability to examine that and see if it's something that you wanted to have happen. And a zero trust architecture is only possible if the integrity of those systems involved is assured. So assessing a security posture is going to require integrity. So you're going to have to look at a number of things. Your trust policy is always evolving, especially in Windows. That's a big part of your security. It's probably 85% of your security and group policies. The requests coming in the network from assets, from users, from apps. And then it's assessing the risk of all these things, internal to the network and external to the network. So again, with zero trust, you always want to know, can the requester be trusted to access that particular resource? And each step along the way, you want to be able to ensure that. So you're going to have to validate identity. You're going to have to identify or validate their security posture at the time. So for example, you might run a scan for patch updates. Are they current? You're going to run a scan for vulnerabilities, but potentially you're going to check credentials for establishing identity. And it's not just one thing. So you're looking at the configuration of the devices, any vulnerabilities that exist, whether or not that machine's in compliance, whether or not monitoring is occurring, and whether or not you're applying threat intelligence to those individuals and those devices. So having a secure configuration is very important to that and monitoring for integrity. So for example, just every network pretty much is on the federal side is going to comply to NIST 853, the SI 7 requirement for some type of file integrity monitoring. Again, we take that beyond just file integrity monitoring. We're looking at the firmware, directories, registries, the operating systems themselves. And policy compliance is also very important, because policy compliance is going to be your first clue that perhaps you're in a non-secure state, and cause you to go back, get back into that secure state and look at other things that might affect what could impact your security. Vulnerability management is a big piece of that. Not really going to focus on it today heavily, but Tripwire does offer our IP360 solution, which does vulnerability management and vulnerability scanning. Tripwire Enterprise, which we are going to focus on today, is our integrity monitor. And it's important because obviously unauthorized changes is an indication that your device is either not being managed properly or it's been changed and it shouldn't be trusted to access resources. So again, just to review this, zero trust isn't a product, it's a concept. Every incident is going to begin with a change. Any incident is going to involve multiple changes. And integrity monitoring is more than just change detection. It's foundational to zero trust. And assessing your security posture is going to require that you have integrity. So here's a slide where we've addressed one of the risk management frameworks, capability models of zero trust. Everything that's in orange is something that Tripwire Enterprise does address. And I believe you guys have a copy of the slide deck as well for later reference. And there's also a chart in here where we talk about what we actually can do using Tripwire Enterprise for all the various components of that particular model. So at this point, I want to pass this off to Dave Henderson, and we're going to actually show you a demo of Tripwire Enterprise and show you how some of what I discussed can actually be seen and come into play. Dave, you may be on mute.
And good morning, everybody. Yes, I was on mute. Apologize for that. And thanks for catching that, Dan. This is the Tripwire Enterprise dashboard. I'm going to start right here. But before I get going, as Dan had mentioned, I've been with Tripwire for 12 years, almost 13 years. And I'm currently in the capacity of managing solutions engineering team within Tripwire, and also called upon to be a federal SD subject matter expert when it comes to this product and a few of the others. And prior to working with Tripwire, I worked for BMC Software. I worked in the federal market as a contractor for SAIC and for back in the day Boeing Computer Services, and so many years with those companies. And I spent about 8 years in the Air Force after school, and here we are today, and it's been a nice little ride. So Dan was giving you a presentation there on zero trust, and he talked about baselining, and baselining is a concept that Tripwire Enterprise does very well. And essentially a baseline says, hey, I'm going to take a snapshot, if you want to call it, of what a specific system in my environment or all my systems look like, and then that's going to be my reference point going forward. Okay, so you can run reports such as a baseline report, and if I took a look at, matter of fact, I have this one here. This is what a typical baseline report looks like. And so this is off of a machine that I'm going to be doing some demoing off of today, which is a CentOS 7.6 machine. And it shows just the critical elements in this case. And so if you run this specific report, which is a baseline report, it will show you what items that I baselined and that I'm currently monitoring from a critical perspective on this machine. And so this report goes down. I believe there's over 2,000 different elements that are being monitored here just in the majority/etc folder. So I'm going to close that. And that's typically what a baseline looks like. Okay, so you've got that type of a baseline for all your machines, your systems out there. And the nice thing about it is I don't have to run and go and grab that baseline every time I turn around to try to find something. That information is put into Tripwire Enterprise's backend database. It's actually stored there. And so that makes things very convenient, because going forward, after you've done the initial implementation of the product and you've done your baselines, the agents, or in some cases agentless, okay, but let's use agent as an example. We've got agents deployed out there on all your Linux machines, your Windows machines, AIX machines, Mac OS, etc. And so we've got these agents sitting out there, and those agents can run in real time or just be set up to do periodic checks. They're connectionless, okay, so therefore they do not have to have a connection to the console. And so if they're running in real time, for instance, and they're collecting change, but I don't have access to the console for some reason, then that agent will cache the data that it's captured as system activity that related to change. And it will cache it. And once it's able to establish a TCP/IP route back to the console, it will forward that cached information so you don't lose anything. So it's lossless. All those agents have a unique ID. So if a system IP or host name or something critical changes on the machine, then, Tripwire Enterprise just updates that information in our console. So you don't have to worry about making a change to a system and then potentially seeing maybe a duplicated node created or something of that nature. But anyway, that's typically how that works. And those agents keep that data that's in the backend database up to date. And that's the critical point, okay? If you're running a compliance report, no, I don't need to rescan all my systems out there to get a DISASTIG result. I just run the report because the data is in our database, and it's up to date because my agents keep it up to date. And so that's very important when it comes to, for instance, the boss calling the security administrator and saying, hey, I need to know how compliant the systems in the payroll department are as compared to the systems that are in the mailroom, for instance. And so that individual can run that report literally in a couple of minutes, have it in his boss's hands. Okay, so it's very, very, very popular in that manner. So let's start out here by looking at some of the dashboards. I've got the integrity monitoring dashboard open. I've also got security dashboards around some of these cybercrime controls like Dan had mentioned, and this is looking at changes to breach detection, like installed software, new executables, network shares, scheduled task changes, startup tasks, local users groups, startups, etc., processes, services. And then I'll move forward. I'm not going to go through all of these, but you'll see the MITRE attack. If you get questions, Aaron, would like to see that. Firmware, if I'm looking at changes to firmware on my endpoints, that's very important. And then here's an example of a NIST 853 high security control dashboard. Of course, we have over, gosh, I want to say 2,500, 3,000 policy/OS combinations in our library. And this is just the NIST 853 high for Windows and for Linux. But, I also have dashboards in here for PCI, for DISASTIGs, for CIS, and over here in my little helper bar, if I click my home pages tab, you'll see I've got a whole lot of other home pages that I built that I can add as tabs here. Okay, so not going to go down that path, but I'm going to start out by talking about change. Okay, so you've seen what a baseline report looks like. Let's go in here to this report called changes by severity. Okay, when I click on that graph, it's going to open up another graph which shows me graphically how many changes are occurring based on the vulnerability level of the change or the endpoint. And so then we've got them broken out by risk severity down here as well. You'll see the systems that I'm monitoring, the type of system, the last time a change occurred, excuse me, and the number of changes. And like I said, today, I'm going to focus mainly on this CentOS machine here because I've been making some changes to it, and I'll show you what real-time looks like. And that's got 10 changes. So what are those 10 changes? If I click on that number 10, then I'm going to get a little pop-up that allows me to run any report I want to run from this list against those 10 changes. But let's just say changed element. Show me the 10 that changed. So I get this list here. In this particular case, it shows me the date and time a change occurred, what element changed, what item was modified on the endpoint. The last time, the type of change, which could be a modification, could be an addition, could be something deleted, etc. And the any attributes that were modified and the user that made the change. So these are critical summary components, but if I want more detail, then I'm going to click this little button up here called Elements View. And Elements View then converts all that data to a link. Okay, so I can actually drill into the item that changed, look at the event data related to that change. I can look at modifications. I can look at the specific change of an element. We keep an historical record, so this is the current version. And then I can actually open up the rule over here that actually included the change. Okay, so what we're going to do here is we're going to take a look at, for instance, this etc password file. Okay, so somebody's added a new user most likely or deleted one. It's a modification. Let's take a look at that. In this particular case, these are items, user, the file's been modified and its information is in green. So you can see 2 new users have been added to the system, a user by the name of Havoc and another user by the name of Frankenstein, being October. Okay, and so we have the baseline on the left, and that's why we, are hammering home what a baseline is. That's what this file looks like. That's what it was baseline to look like. Over here on the right is what it actually looks like. Okay, with the changes. And so this is critical information. And then I'm not so sure that I've got my. Take a look real quick and see if I've got my don't know if I have that open or not. No. Okay. I'm going to open up the virtual machine library and turn on my log management solution just so I have it running in the background. And so this is a completely separate solution. This is Tripwire Log Center. And I'm turning it on because I want you to be able to see how the Tripwire Enterprise is creating events and how those events are actually forwarded and stored in a log management solution, such as Tripwire Enterprise, Tripwire Log Center, but also it could be something like Splunk, okay, or any other log management tool that you might be looking at out there. So if I pick on this same CentOS machine, I'm going to click on a server name here. And when I click on that server name, you'll see that there's a tab called Log Center Events. And I just opened up my log management solution. So hopefully we'll be able to pull in some event data here. And so you're seeing here event data related to this specific user, Mayhem. So you can go back in time and take a look at what changes this guy has actually put onto the system. You can also see where he's changing his privileges, SU himself to root, etc. So all the event data related to the changes that are occurring are going to show up in here as well. So I just wanted to show you that. And that's data that's going into Tripwire Log Center, but it's the same kind of data that would be going into a Splunk or a log, like I said, a logarithm, and ArcSight or any other log management solution that should you choose to forward that information over to. Okay, so let's take a look at real quick what a rule looks like, since I can look at the rules right here. This is a critical configuration file rule, and this is one of the rules in the system, only one of many, many, many rules. But you can look, and I open that rule and I select the specifiers tab. It shows you all the various different elements that this monitor is, this rule is monitoring. Okay, not only that, but it shows you the attribute set. And so if we take a look at, for instance, the etc login and look at the attribute set or the criteria set called Unix content permissions, well, what is that? If I click on it, it actually will show you in another pop-up window here, if we're looking at a file here, the ACL permissions, the group permissions, permission, SHA-1, hash size, and the user permissions are all being monitored in addition to the data inside the file. directory. If it's a directory element, then we're looking at just the permissions for the most case. Okay, so anyway, that's literally what that is. And rules are what dictate is baselined on a machine. Okay, so if I specify a whole group of non-critical plus critical plus policy rules to be baselined on an endpoint, then I may end up having a set of close to 25,000 different elements that I'm monitoring on an individual machine. Okay, so that's what we've got here. If I looked at another one like the login.definitions file, that's a security control. Okay, so what's changing in that file? Click on modification and you'll see the baseline over here, which looked pretty normal. 90 days for the password maximum days, minimum days 30, length 14, age 30, but this again has been modified now to show 40, 10, 4, and 5, which is way out of spec. Okay, so anyway, that's a modification, and you'll see it's red down here. So this is not just an inserted data or deleted data, but it's actually changed data. Okay, so baseline on the left, change on the right. Okay, so that's critical. So let's go ahead and close that. And real quick, I'll just show you something else, such as like a let's pick on a Windows, not a Windows, but let's pick on a Cisco device. Okay, so we've got a Cisco ASA firewall. Okay, the running configuration's been modified. Ooh, network engineering team's not going to like that. So I go in here and take a look at this and click on modification. And what I find out in my, again, this has been baselined, is that somebody has gone in here and just added a banner. So they didn't do any damage, but they're basically saying, hey, network team, I just broke into your device and, added a banner, welcome to indoor. Okay, baseline on the left, change on the right. Critical information, network team's not going to like that, and so they'll take a good look at their security practices to see how somebody could have actually gotten into that machine or into that firewall. So anyway, we can look at other things such that are critical, such as databases. For instance, if I'm looking at let me see if I can find one of those, SQL server down here. So in this particular case, I'm looking at a new user or two being added to access the database. But more importantly, I've got this embedded payroll query that's been modified. Excuse me. So I'll click on Elements View, and then I'm going to look at the modification to that query. That's what's caught my eye here. Okay. And sure enough, in this case, the baseline of that query is on the left. And by the way, we don't show every line in this side-by-side view. We capture every line, but we truncate the view down to just focus on where the change is. Okay, so in this embedded query, somebody has gone in here and added an ID, a last name, first name, salary, health, vision, and vacations. Okay, so added and made some modifications to the query to pull this PII information. Okay, so that's very critical. Next time this query runs, all this PII data is going to be captured and funneled out, most likely, to whoever this individual is who's trying to harvest or pull that information. So that's a critical look at just one of the items that we look at in a database. And it's not just, we have many, many rules for databases. So we're looking at not just what's laid out on the disk for the database, but the internals of the database, like I said, embedded queries, stored procedures, all of the concepts around the database names, the tables, the fields, all of that information in the structure is being monitored as well. So we'll close this. And before I jump into the second component that Dan had talked about, which was compliance, I'm going to jump into a breach. Okay, so this is something that's critical. And in this case, I'm looking at a Windows machine, Web1 State Gov, with 6 critical changes. Now, when I look at those 6 changes, what I want you to focus on here is the breach itself, the time. Okay, timing, 10:10 a.m., 10:42 a.m. So in the space of 32 minutes, this system was totally breached. Okay, so you'll see the very first thing that happened is a local user was created on the system. And then that individual logged in, name of A. Hatcherman, and dropped the file on there called opendoor.cmd, which is a version of Netcat, if anybody's familiar with that. And then you'll see here that I've got a new process running in the background with the new port attached. And then a little bit later, I have an established session to that machine and another file dropped on the machine. Now this file it shows it was dropped on by this guy named A. Hatcherman, but in reality, if you're familiar with the way Netcat works, whenever the client side of this exploit executes, the individual attaches to the machine and assumes the login ID of whoever owns the process, okay, which is A. Hatcherman. Okay, so anyway, let's take a look at that just to verify that this is actually real. So we go in here into Elements View. And so for local accounts, and before I even show you this, I would like to state that Tripwire Enterprise has an Actions Manager. And the Actions Manager gives you the ability to build automations and workflows into this product to take automated action. So if I have policy in place that says you should never ever be able to create a local user account, okay, but let's say somebody does, okay, so well, we can block that, not block it, but the account gets created and we can immediately disable the account, delete it, okay, move on, literally, almost immediately. And so if that happens, let's say, that did happen and no action was taken, individual logs in, is able to drop a file on the machine and explode it. Again, when this new file is added to the machine, considering we have a whitelist profiler type tool, we call it Tripwire State Analyzer, we can look at that and see whether or not that's authorized software to be on the machine. If it's unauthorized, then we can move it, as I like to say. You could delete it, but we can move it, take action, move that file to some quarantine location so I have my artifact, right? And keep it immediately from being utilized in any way, shape, or form. And I can isolate the machine. Okay, so I have that happening. But if I get through and that machine, nobody's taken any action, and that file's added, it's exploded, I have a new listening port, I have a new process, again, I can kill that service, eliminating the port, and isolate the machine. But let's say that doesn't happen. So this individual possibly types in a message to his buddy on a throwaway cell phone in some other country and says, hey, the back door's open. That individual executes the client, attaches to the machine, and drops another file on it. And of course, while they're on there, and he's on there as an administrative user at a command prompt, he could, at that point, be able to run nmap scans and see what else he could do to, worm himself around the network and do other types of damage. But let's take a look at this. Now, I didn't take any action, otherwise I wouldn't be able to show you this. Now, if I look at the modification to a local user account, then that's exactly what that is. Baseline on the left, here's a new user named A. Hatcherman that was added to this machine, okay, at 10:10 a.m. And then we look at an added file. This is a file that was never baselined. Therefore, I have no baseline because it's a new file. And so everything over on the right-hand side of the screen is related to hash information, essentially. And so there's my hashes. I can use this information to engage threat intelligence to see whether or not these are known indicators of compromise, okay, and take action against it. Okay, so let's say that gets through. Excuse me, then I have this new listening port. Let's take a look at that. And the listening port is going to show that the new port is 3333, running on a process ID of 2864, okay? And so 2864 is service process ID, port 3333, new port, okay? Let's go up here and look at that established session. And sure enough, that established session is attached to port 3333, same process ID, 2864, and you can see the bad guy's IP address coming in right here. And so that you might be able to use that information to track backwards to try to figure out who that individual is or who owns that system where it's coming in from. And then of course, if we want to see what the process is, then we can actually click on the process here, scroll down in this list and look for 2864. And I'm probably going to find out that it's down here in the lower section. and it's running as a print spooler. So it's a fake print spooler running in the background, which is actually the malicious code on this machine. Okay, so anyway, there's that. That's a breach. I'd like to, I don't know if we're doing Q&A at the end, but if there's anybody that has a question, I think that's what we're going to do. So you might want to hold those till we're done here. But let's go into one other thing around change, and that is what happens if I go into a system and make some change. Okay, so let's say this machine is running in the background. It's a Synthos 7 machine. It's running in real time. And so let's say that I am a bad guy and I want to make some changes, let's say to the logs on this machine to try to, for instance, cover my footprints. Okay, so first of all, I may have to give myself some permissions. Okay, so I'm going to go in here and I can see the permissions for my let me do a PWD here. You can see I'm in the var log directory on this machine, and I've done a quick look at what the var log messages logs happen to be, and there's 5 of them. And so I, want to clear out any indication of myself ever being logged into this machine. So I have to do that by giving myself access. Okay, now currently I'm logged in as root, but later on when I do some damage, I'm not going to be logged in as root, let's say. Okay, so I'm going to go in here while I am SU'd as root, and because I gave myself those privileges, and I'm going to run like a chmod 606 on mess star. Okay, so now if I do an ls-la on my messages files, you'll see that I've given read-write access to not just root, but to all other individuals. Okay, so now I could, in fact, VI, for instance, I could go in here and VI the file that has my login information in it. Okay, and then I could go in here and look for mayhem. And I can see there's a first instance, so I may want to do a delete DD, delete that line, and then hit next, delete that line, go on through this, delete all instances of me being logged into this machine. Okay, and so that's literally a concept of I made a change there to the permission. So this is running in real time, so I should see that information over in the Tripwire Enterprise console. And so let's take a look at, for instance, all these configuration files in here, and you can do an ls star.conf, and you'll see there's a lot of configuration files. Most of these are security controls, and so if I wanted to VI or edit one of these, let's just pick one out here and do the one at the very end, yum.conf, and VI yum, and just simply, I'm going to, in this case, just go down here. Let's mess up yum's ability to do any kind of work. Okay, well, let's just add another comment. Okay, new comment. So I'm not really doing any damage here. Write that, and whoops, I'm sorry. It's a comment line, no big deal. Okay, so I've got some changes I made to that machine. And if I go in here, I can either look at them in a graph on my home page here, or I can go into my nodes manager and find that specific node and drill down into the node and look at it from there. In this case, I'm going to open this guy here, and you'll see that the changes that we were dealing with were on this machine here, and you can see there's now 15 changes, and I'll click change elements. And so you'll see that there's changes to yum.conf, there's changes to the varlog, all 5 of the messages files. Okay, so we do a element view. Okay, and when I look at that element view, and for instance, I look at varlog messages modification, you'll see that the permissions went from read write for root 600 to read write and read write for other 606. Okay, so that happened in real time. And I can also look at like the yum.conf, which we just made a change to. In this case, we're capturing content, so we can see the new comment that we just put on there. Okay, so anyway, just wanted to show you that's what real time's all about. And so it's critical from a zero trust perspective to be able to monitor individual components on your endpoints in real time. It doesn't have to be everything on the machine, but the critical components, okay, the items that are keeping that system secure, okay, monitor them in real time to make sure that those policies that your security team has put in place remain in place and stay in place, okay? The system remains hardened, okay? So let's move over, take a look at NIST 853. Okay, so I could pick on Windows here, pick on Linux. Let's go ahead and pick on Linux. But what this is doing here is it's giving me a trend of my max, minimum scores, etc., average scores over time for both OSs. And then here I've got a summary, okay, and I'm going to open this. This is on Linux, and this is showing me the information regarding the operating system. And you'll scroll down. If I've got multiple operating systems, you'll see them in here. So there's RHEL 6, and I've got CentOS 7 in here, and I may have some other versions down there as well. But let's pick on this. Okay, so under NIST 853, you'll notice it's broken into different categories: AC, AU, CM, IA, IR, etc. If I look at identification authentication, I'll pick on that. I got 10 failed tests, 12 pass tests, 59%, 55% compliant, okay? Not where I want to be. So I'm going to click on the number 10, and this will open up a report that's pretty critical. So in this particular report, which I think is important, you'll notice up at the top of the screen, you've got a PDF export, an XML export, a CSV export. I can email it, okay? And I can also go into a test results view and view this failed test in a spreadsheet type format. So real quick, again, these are my failed tests. You're looking at the first test that failed, gives you the identification of the test, the purpose of the test, the name of the test. We're verifying that the SSH config file contains max host tries. And again, this is the purpose right here. And if we scroll down, we're providing you what's called remediation guidance, okay? Step by step, how do I fix this problem? So I'm going to go in here and become super user, open this file and make, the change that I need to make, set a value, run the pkill HTTP to SHTTP command, blah, 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 restart the service. And you'll see if I scroll down in here, if there's any reference on the web regarding this policy, you'll see that in here too. This one doesn't have any. And then you'll see the result failed. Why? Because my SSH max auth tries is not set up at all. Okay, so there's no value extracted. We have the policy set up to where if you don't have a value set, it's an automatic fail. Okay, so if you scroll down to the next one, again, there's the steps that you have to take. Now, if there's a script that has to run, we're going to provide you with that script as well. Okay, we don't expect individuals to know all these commands, etc. And some of them are very, very lengthy, and you wouldn't have an SA that understands all of this syntax off the top of their head. There may be one or two out there, but I'm rest assured somebody probably does not know how to type all that. Okay, and so in this particular case, we're looking at verify that the user's last password change date is actually in the past. Okay, and so this is how you do it, and that's the script you run to fix the situation that you're failing. And so anyway, if I go up here and click on and by the way, before I even do that, this report is a good one to click email on and send the email to the change review board, so the CR change review board can look at these failed tests and make a decision on which of the, in this case, 10 failed tests, which of these 10 can be remediated without causing problems. So that individual that's doing that review, must be pretty aware of the security policies for the agency and know what applications are deployed. Some security controls you can't put in place because they'll break an existing application, a legacy application that's heavily used, for instance. And so in those cases, you may have to put an exception or something of that nature in place. But this is a great report to send to them so that they can, pick and choose which can be remediated. And by the way, Tripwire Enterprise does support automatic remediation. Okay, so we have the ability to put the commands and scripts in place for each policy test to automatically fix it for you. Okay, but let's click on test result view. And so, like I said, this breaks this stuff, these 10 failed tests down in more of a spreadsheet format and a little easier to read. I can go in here and say, like, for instance, to verify that the password must be 14 characters or more. We failed on this particular system. And of course, I didn't run, the last time I ran the check on this system was back in 2021, but we failed it. So let's say that I need to put a waiver in. So I select that, and up here I click new waiver, and then it's going to present me with this form that I fill out, the name of the waiver, select the policy in here, and I've got all kinds of policies loaded in my machine, but I'm going to go down through here and select the policy that applies for this specific failed test. And in this case, it's going to be the REL 7 NIST 853. And whoops, I select 171. It doesn't matter. You find the one that says NIST 853, Rev 4, Rev 5, put the name in, who's granting it, just give somebody's name in here, or you can drop the menu down and select an individual from the list. And the reason why you can do that is this is a fully role-based access control product. So we didn't talk about RBAC, but it's the full RBAC product. And responsible could be Susan. And again, it's drop down. If there's anybody with that role, you can select them from the list. And in this particular case, give it a description. And then down here, you can say that it expires in 90 days, or we can say never expires. And if we do that, then we put next. And in here, we add the nodes that this waiver applies to and click finish, which we're not going to do. Okay. And so anyway, that essentially gives you the ability to put a waiver on those specific devices. And so that's a typical compliance view. Now we have scoring reports, we have scorecards, we have waiver reports, we have all kinds of reports. As a matter of fact, if I go in here to the reports manager and I actually select new report, you'll see there's a slew of reports that Tripwire Enterprise has built into it. And each of these has a set of criteria that can be clicked and changed and modified to give you the type of information that you're looking for in your specific reporting capabilities. And with that, Dan, I'm going to hand it back to you and see whether or not there's any questions.
Thank you, Dave. Great job. Very thorough. I'll just open it up to the floor. Are there any questions at this point? I know we just saw a lot of information, but if anyone has any questions just about Tripwire Enterprise itself or how it relates to Zero Trust?
Definitely a lot to digest.
There's a question from RKC Turner. Everyone, are agents required for all the information? So we do put agents on our servers, workstations, network devices are managed agentlessly. So anything we can establish an SSL connection to, we can manage agentlessly. That wouldn't be real time. That would be a scheduled monitoring, but everything else would be real time and done through an agent.
And I would add that there are appliances out there and appliances that have like a Linux operating system, for instance, and you can't put an agent on them. It's not allowed to, let's say, but we can monitor those devices. We just SSH into it and pull all the same configuration that you're seeing in here using Unix file rules and what we call command output validation rules. So we can monitor those appliances, whether they're physical or virtual, that have like a standard operating system running on them, but they're so locked down you can't add software to them, so you couldn't put an agent on them. But we can definitely monitor those agentlessly as well. But the preferred method, okay, so that you can get real time, is to actually put an agent on anything that is a typical operating system.
Thanks for that. Are there any other questions, perhaps? Our goal here today was just kind of to be able to demonstrate how there's so many things that it could influence any one component of an architecture that could impact its ability to be a trusted element within that architecture. And I think you can see there's a lot of granularity that Tripwire Enterprise can provide to help you ensure that and identify where those changes occur.
Right. One of the things that we didn't talk about, Dan, was tagging. And so concept of tagging is very important. And I went into what we call asset view. This gives me a list of all my devices, and I can filter on that by selecting any one of the items over here in column 1, including a health manager. So if I've got issues with agents or something, then those are going to show up over here. And I can drill down and figure out what's going on there. But let's say I select a machine, and I did pick on this Windows machine, or actually let's pick on this Windows 7 client machine. It only has 2 agents, okay? I mean, two specific tags associated with it. It is an Axon agent, and it is part of the Windows family. Well, I could edit that, edit tags, and I could say, hey, you know what? This is actually a very important machine, so I need to make sure that I also have the mission critical tag associated with this machine. So now you'll see it's mission critical. And so when I go over here to my nodes manager and I look at, for instance, that tag set and called asset priority mission critical, you'll now see that the Windows 7 machine that we just tagged falls into that group. Okay, so the reason why this is important, this whole tagging concept, is, and I'm looking at mission critical right now. Again, if you wanted to run checks or reports or compliance tests, and whatever you want to run against a set of machines out there, maybe you want to know, hey, you know what, how critical, I mean, are all of my mission critical machines scoring it above 90% on compliance, for instance? Then I run my report against the tag mission critical. Okay. And so I don't have to remember the machines. I just have to know what the tag name is. And so going into asset view, you'll see the blue section here, and these are tags that Tripwire Enterprise automatically associates with devices. But the orange section is your section. This is your playground where you can go in here and build your own tag sets and build your own custom tags. For instance, I'm looking at, if I look at location here, I've got Atlanta, Fairfax, Kansas City, San Francisco, Washington, okay, listed here. But you could add, you know, whatever locations, wherever your particular environments happen to be, add them as a location and tag your systems by location as well. So just an example. And so anyway, that's where we're at with that. I just wanted to throw that asset tagging in there too while we you know, had a few more minutes. So back to you, Dan.
Thanks, Dave. Any other questions at this point? Anything we could elaborate on, perhaps? Well, if not, we would like to thank everybody who joined us today, and thanks for participating and allowing us to give you a look at Tripwire Enterprise.